Hi guys, welcome to my channel. My name is Alam. So today we will start distance matrix in machine learning. So we have two distance matrix. One is Euclidean distance, another one is Manhattan distance. So we will talk about both distance today. So what is Euclidean distance? So Euclidean distance, suppose we have one line, okay, and if we give one line, the name of this line, one is A, point number A, another one is point number B. Okay, so A has x1 y1 and B has x2 y2. Okay, and the distance is D. Okay, so this Euclidean distance, if I add a dotted line, this one and this one, so do you find something similar, something common, right angle triangle, something is similar to this theorem? Okay, and that theorem is Pythagoras theorem. So it looked like Pythagoras theorem. Okay, so this way we measure the distance from one point to another point. So we have a formula of Euclidean distance. This is the formula of root over of summation xi minus yi whole square. So if we expand this formula, it will be look like this: x1 minus y1 whole square plus x2 minus y2 whole square under root. Okay, so this is the way we measure Euclidean distance between 2 points. Okay, so now we will use another one is Manhattan distance. In the Manhattan distance, we will not follow the that pattern. Okay, what we will do is we will do this. We will follow this pattern and then this one. Okay, so here you can see in this Euclidean distance, it looks like staircase. This one, this one, this one, this one, this one, this one. Okay, it look like staircase. Okay, so Manhattan distance follow staircase pattern. Okay, so so if we have the value A and then we have the value B, so its formula will be D of summation absolute xi minus yi. So absolute value means that we don't want negative value. If any value is coming negative, we make it positive. That's why it's absolute value. Okay. And this Manhattan distance comes from the name Manhattan distance. It has taken the name from city in US. It's called Manhattan, New York. Okay, this is the city name in the US. So from there it comes the name Manhattan distance. Okay, so Manhattan distance can also be known as taxi cab. It is also known as taxi cab geometry, or it is also known as city block distance. Okay, so the question comes where to use Euclidean distance and where to use Manhattan distance. Okay, so what we will do is, suppose you take a flight from Bangalore to London. Okay, so from Bangalore to London, what we will do? You take a flight. Okay, so this is my Euclidean distance. Okay, this is my Euclidean distance because you're taking flight. Okay, you are you're going by air, right, from Bangalore to London. That is my Euclidean distance. Okay, what happened? That is a one case if we got it. Another one, what happened is, see, if you want to go from Rockefeller Center, that is, this map is in the US. I have taken from US. So this is the one Rockefeller Center to Times Square. So you will see the dotted lines here. You will go by this, you go by this, you go by this line. Okay, these dotted lines are Manhattan distance, and this dotted red dotted lines are Euclidean distance. You can't go. So these all are blocks. So you can't go jump from here to here. You can't go from this location to this location by air. So what you follow this pattern. So what we will do is we will do with the help of Python, and we will solve Euclidean distance and Manhattan distance. Okay. So if we have taken the value A have one number 135, B has 427. So what we will you will run this code. Okay, so we have A and B. So we want to find out the Euclidean distance. Okay, so Euclidean distance, we have the formula. So if you print the value, it will giving the value 3.74. So what about Manhattan? Let's see. Manhattan is giving 6. Okay, so this is the way we use Euclidean distance and Manhattan distance. And Okay, so Euclidean distance is basically used. This is the most distance matrix used in the our machine learning. So Euclidean distance basically used in KNN. Okay, and another one is K-means. Okay, okay. So KNN is basically supervised, and K-means is basically unsupervised. In this two algorithms, we use Manhattan distance and Euclidean distance. Okay, K is basically KNN is basically K nearest neighbors. So we when we have our data points, okay. So what will happen is that if we want to see the distance between two data points, which is nearer to the which is very near to the center. So that time we use this Euclidean distance to see which data set is nearer and which is very far. Also, we consider as an outlier. Okay, so this is the way. So these two Euclidean distance and Manhattan distance are used, and I hope you got some idea about Euclidean distance and Manhattan distance. So thank you very much. Please just like and subscribe my channel, and we will see you in the next video. Bye bye.